Okay, so number 2 says the following gases are introduced into a closed 0.5 liter flask. So we have this many moles of each compound. In which direction will the reaction proceed to achieve equilibrium? So we have the K value. So the Q setup is the same, which is our N2O4 over NO2. So there's just an extra step here. So instead of them giving us the concentrations, they're telling us the moles and the container that it's in. So we would actually have to solve for the concentration for each compound. So remember, C is equal to N over V. So if you think about it, look at our units we need. We need moles per liter, right? So we do moles divided by liters. So here we end up getting, let me get my calculator. Hold on a second. I'm going to pause the video. Okay, so we end up with 3 moles per liter. And actually, I'm not worried about sig figs here. It's actually 3 bang on. And the concentration of N2O4, which is going to be our 4 moles divided by 0.50 liters, which should be 8. Just double check on that. Yes. So we have 8 moles per liter. All right, so we're going to plug those in. So we have N2O4 is 8 over 3 squared. So we end up getting a value here of 8 divided by 3 squared, 0.89. So that is, if we compare it to our K value, so our K value is larger. So Q is still smaller than K in this case. So it will have to shift to the right in order to proceed to get to equilibrium. And then number 3, we have in a container, we have these concentrations exist in equilibrium with, okay? So we have these in equilibrium. So these are our equilibrium concentrations. It says then a buffer is added that increases the concentrations of both the bisulfate and sulfate ions by this much. What happens to this as the equilibrium is restored? So in this case, first of all, we're not given the K value at all. So obviously this is why they're giving us the equilibrium numbers. Okay, so let's take a look at our KEQ originally. So we have our hydrogen and our sulfate over our bisulfate ions. Okay, so at equilibrium, let's take a look at this. We have 0.1 and 0.1 over 0.83. So our K is 0.012. All right. So then they're asking us, it tells us, so for Q, it's the same setup, but basically we want to know, let's see, our hydrogen is the same because we're not increasing that. And it says our sulfate is increasing by 0.1. So really that's like 0.2 because we started with 0.1. And then our bisulfate is also increased by 0.1. So this is going to be 0.83 plus that, which is 0.93. Okay, so our Q value here, our Q value is going to end up being, let's see, times 2. 1.3. So we get 0.022. So our Q value is larger than our K. So in this case, what's going to happen to our bisulfate as equilibrium is restored is we're going to have a shift towards the left in order to get back to equilibrium numbers. So eventually what's going to happen to the bisulfate, which is our reactant, is this concentration is going to have to increase in order for equilibrium to be reestablished with these new concentrations. The wording on this one is weird because they told us what the bisulfate concentration is changing by. This is like another way of them asking, like, what's the shift, right? So what's going to happen is we're going to need to increase the reactant amounts. So it's going to increase due to the shift to the left. And there's too much product in that case. Okay, the last part of this, the last part to this is just a quick little mention about, now that we understand how the case setup is that once you know solids and liquids are not included in your K expressions, when we start looking at changes in concentration and their impact on K, if you have a case where there's only one substance that is actually influencing your K, you start to realize that that's really the only thing we care about. So for example here, the solids are not included when we do our K expression. So really this is like carbon dioxide over nothing or over 1. So the carbon dioxide concentration has a great impact on what the K value would be, because literally they're essentially equivalent. So equilibrium that have only one chemical concentration completely alleviates any stress that changes that concentration because they're directly influenced. So if we have an increase in carbon dioxide, that means that our K value, right, we're definitely not at equilibrium because it's going to have too high of a number, right, once we start looking at our Q values. So essentially when you have only one compound or one molecule, I should say, that is gas or aqueous in the entire reaction, that one is going to create a large stress to the system because it's the only one really having a direct impact on the Q position. All right, so I believe you will need that information. I don't even think you actually need, it's just something to keep in mind. I'm trying to see. I don't think that any of your homework has to do with that. There might be one question towards the end where it just asks you to discuss basically, the K expression and how it would be impacted by a change in that substance. Okay, so that is it for section 2.5. See you soon. Bye.